Okay, so you're here to watch, you're here to learn some logic design. So the first thing in logic design that you need to know, I know you're raring to go, but the problem is we have to set some ground rules. So the first ground rule is um, how can we get a computer to interpret numbers and manipulate data? Because fundamentally that's all they're doing. They're manipulating data. But how can we get computers to manipulate data, or how do they manipulate data? So to answer that question and to lay the first foundation, we have to understand how numbers are represented in computers. So to do that, we need to learn how to go from a number, say 9 in base 10. And when I say base 10, that just means it's in decimal form. It's a normal number that you're all used to. And we want to go to a number that a computer can understand. And it just so happens that computers understand base 2 numbers. And base 2 numbers have a little subscript base 2 down there. Usually you have to write the base that you're working in. When we're in decimal, you don't need it because it's just assumed that you're in decimal. But when we're working with anything else, like base 2, you need to write your subscript. So now the question is, how can we go from decimal, the decimal system, to another decimal or another system, another number system like base 2 that the computer can utilize and manipulate? So to do that, we need to first off, uh, I guess the first thing that you want to do is take your number that's in base 10. So in this case, it's 9, and you want to divide by the base you're going to. So in this case, it's 2. So we have 9 divided by 2, right? So 9 divided by 2, 2 will go into 9 how many times? It goes in 4 times, right? So then we get 8. 9 minus 8 is 1, that's our remainder, and now 4 is our quotient, right? So now we take 4 and we proceed to do this division until this top number up here is 0. So now we say um, our new number is 4, and now we divide again by 2, which is our base. And how many times can 2 go into 4? It can go in twice. So 4 minus 4 is 0. Now I forgot to mention what we do with our remainders down here. So the remainder, the first remainder that we get for the very first division we do is our what we call the least significant bit. Now the least significant bit is just a shortening of binary digit. So which is the number system we're working in, which is binary. So the least significant bit is the rightmost number of the overall number. So like if I wrote 10,589, 9 here in this case would be the least significant digit, or it's in the ones place, right? So now we say this 1 right here, this remainder, goes to the least significant bit position of the base 2 number. We're not done yet, so there's still more stuff that goes out here. And, uh, and so this 0 actually goes into the next spot. So now we have 0, 1 in base 2. So now we keep going with our division process. So now we take 2 and we divide by 2. Now 2 only goes into 2 once. So 2 minus 2 is 0. So now our next number is 0. And so this number is still not 0, so we have to keep going with our division. So now we have 1 divided by 2. And 2 can't go into 1, so it goes into 1 0 times. Now we're done. We know this is the signal to stop the process. So we are done, we're finished. So now this, whatever number we get from this, is our final number. And it just so happens that the final number is 1. The 1 here is a remainder. We can't go any further than this, so our 1 is the remainder. So now we put a 1 out here. So now our final binary digit from base 10 to base 2 is 1001 in base 2. Now we can do another example. Let's see. Let's do 11 in base 10, and we want to take that to some number in base 2. Okay, so now we start the division process. So we start dividing, and we take the number that we're using, that we start with in base 10, which is 11, and we divide that by our base that we want to go to, which is base 2 in this example. And so 2 goes into 11 5 times. So 10 minus 11 is 1. So now remember, this is now, the remainder is now our least significant bit. So it comes down here, and we can write it down, base 2. And we keep going until this guy is 0. So now we take 5, and 5 is our new number that we divide 2 by, or that we divide by 2. And 2 goes into 5 how many times? In this case, it's 2 times. So 4 minus 5 is 1. And now we take the 1 and we put it right there in the next spot. And we keep going until our quotient is 0. So now we divide 2 and 2. And as you can see from last time, the only thing that can go into 2 is 1. So now we have 2 minus 2 is 0. Sorry. And now we put the 0 out here. And we keep going because this number has not yet reached 0. And so we have 2 and 1. And also from last time, you'll know that 2 can't divide into 1, so we're finished. So this is 0. And now we know to stop the division process. And 1 is our remainder. So now we put the remainder, the 1, out front. So now we have 1, 0, 1, 1 in base 2, which is equal to 11 in base 10. And that's all for today.